And now let's go to Ilaria. Ilaria Tini is from the Netherlands, here from Amsterdam, right?
Yes.
From Amsterdam University. She was here in 2019 and she gave us a nice tutorial on knowledge graphs.
Yes.
And today she is opening the AAC workshop and the Fall School Day 4. And yeah, thank you very much. For everyone who's from the AAC workshop, unfortunately, due to sickness and other circumstances, the program committee is unfortunately ill, and they will not.
Thank you so much. Good morning, everybody. I don't know whether people online are hearing me, but just maybe somebody will give me a shout in case of major problems. As I was introduced, my name is Ilaria. I'm originally from Italy, but I work as an assistant professor in hybrid intelligence at the Free University of Amsterdam, or in Dutch, Vrije Universiteit. So indeed, I was here before COVID, a long time ago. My field of expertise is knowledge representation and knowledge graphs, but I thought this might be maybe a bit not too technical, but not necessarily relevant for everybody, while I thought it would be nice to introduce hybrid intelligence, which is this new field of AI where our university, together with many other universities in the Netherlands and in Europe, are working. So I'm going to introduce you to this field and show you a bit of the research ideas and research challenges that we are facing. So we're talking about AI that collaborates with people, doesn't replace them, and I'm going to show you why. If this works. If it does not, let's see. Does it work? Yes, it works. Okay. Just to give you a bit of background on myself, I have a background in knowledge representation, but I do apply lots of machine learning techniques and a bit of cognitive theories in different application domains. I've been working a lot with scientists, like social scientists, historians, to use AI to help them building research questions. I've been working with roboticists. That's one of the reasons why I'm here. The idea is to use knowledge representation technique to support robotic tasks, and I also deal a bit with ethical AI, so how to build ethical methods. I'm just going to start the talk by keeping you in the loop. Who's this guy? Okay, we're getting there. Used to be before, not many people used to know. Okay, so Elon Musk, 2015. He says, my guess for when we will have full autonomy in cars is approximately 3 years, 1 year before COVID, 2 years before COVID. This happened? Not really. This guy? Andrew Ng? Who is he? Yeah. Yes, Stanford University. A highly trained and specialized radiologist may be in greater danger now of being replaced by a machine more than its own executive assistant. Okay, so that's in 2016. This guy? Yeah, it's written, easy. He said, in 2017, he said, people should just stop training radiologists and doctors. It's completely obvious that in 5 years from now, deep learning is going to do better. So his prediction was for 2021. Then the world stopped for a couple of years, but we're still in 2023, and I don't think we are there. Every time we are getting closer. What happened here?
Looks like he thinks we do, but
he's really convinced. Then he pulled out of. What happened in 2022? Toward the end of last year. ChatGPT is our work is over. Why are we researching? And ChatGPT will replace humans, and nobody is prepared for that. So that now we are really getting into, okay, AI is going to replace us. The real question, I'm going to discuss today is, why do we want to replace humans? Do we need to replace humans? And what is the reason for that? So I think this is the big question the big problem we're going to talk about. I'm really sorry, I will keep on having to remove this that appears on my screen. So yes, so taking a few steps back. So let's go back in time and try to understand why are we talking about replacing humans. So think about science a bit now. And science has always been a way to extend human capabilities. The typical example, a telescope is a way that helps humans to see where we cannot see, so much far away. The steam engine was invented to extend muscle power. And the car or the plane was a way to extend our own speed. So the idea is that we should not see AI as a way that imitates intelligence. Like, imagine if planes were really imitating nature. Okay, we would have a plane that looks like a bird, quite ridiculous, probably mechanically not even that good, because it would be like putting a nail in the wrong place. So we should actually look at AI as something that extends our own capabilities, our own intelligence, and possibly that collaborate with our own intelligence. This is where hybrid intelligence comes into the picture. So we are really not talking about a science that replaces us, but it extends our own capabilities. And why is it that is it so? It's because what the idea behind hybrid intelligence, our idea, is that AI and humans complement each other. So there's we as humans have cognitive limitations, so we are bad at probabilities, we are full with stereotypes and cognitive biases. When we work in communities, in societal communities, we have in-group or out-group favoritism. We tend to do memory, we have problems in our own memories. And machines, on the other side, they also have their own limitations. So they are poor at generalizing, they don't show creativity, they are not aware of societal values, and are not that good in dealing with rare or unique events. So in this sense, we are talking about a system, a team of mixed agents, human and machines, that complement each other and try to complement their strengths and weaknesses. So if we think about it and we have this idea of a human team, then there's a number of questions that arise, what we call the problem space. Which kind of challenges do we face in hybrid intelligence? So we want hybrid intelligence systems that augment rather than replace human intelligence. We want these systems to leverage our strengths and compensate the weaknesses that we have. We want them to be adaptive, to adapt to situations, because the world is dynamic, the world changes, and these systems need to behave to deal with these changes. And also, because these systems are dealing with humans in society, we want them to take into account all the ethical, societal, and legal considerations that we take into account when we behave as humans. And that's why hybrid intelligence try to come up with a research agenda. So let's say hybrid intelligence, we call them functionalities. So there's the 4 core areas we focus our work on, and that's collaboration. We call them care. And in the rest of the talk, I'm going to show you the main questions for each of these areas and what our students and our projects have tried to do in this context. So we have collaboration, we have adaptivity, we have responsibility, and we have explainability. These are the main areas. And then we've also been working in building a theory, a science of hybrid intelligence. Feel free to stop me if you have questions. I'm happy if we make this a bit dynamic. I'm going to start with collaboration a bit. Thinking about collaboration and hybrid intelligence, the idea is that, so how do we achieve hybrid intelligent systems that collaborate? We start by saying, okay, humans, we as humans do mind reading all the time. So I'm adapting my speech now, trying to predict what you are thinking in front of me. So I'm trying to read your mind. And we do this since we are children. I don't know if the audio will work. I think it's a German video, by the way. I don't know if you've ever seen that. So what does this child do?
He predicts what the man wants to do.
Yes, indeed. He looked at this man, and the man didn't say anything, right? So he only had these spokes, and he was hitting the cupboard. And the child tried to forethink what the guy was doing, and went to open the cupboard so he could put the books in. He probably learned this in his experiences. And what he did, I don't know if you noticed at the end, but he looks at the guy to get feedbacks back. So did I do correctly? What did I predict correctly what I wanted to do? Do you know what this is called? There's a specific term for this mind reading.
Potential recognition.
Yeah, or say again? But theory of mind, yeah. So it's theory of mind. It's this. We don't only have to have a theory of the world. So I don't only have to represent the world in terms of concepts and relationships, but I also need to represent the world including the way the people around me represent the world. So indeed, it's called theory of mind, which is defined as the ability to attribute a wide range of mental states to the others, including intentions, so that's what the child did, hopes, expectations, imagination, desire, beliefs, and thereby interpret, explain, and predict their behavior. That's why we want to do that, because we want to give an explanation to what they're doing, we want to try to interpret what they're doing, and we want to predict what they're doing in a way that then we can act. And this is also very important in robotics context, of course. So the idea is that we can develop collaborative hybrid intelligence systems by including in their representation of the world first or second order theory of mind, because it can be beneficial in competitive and cooperative situations where you have two agents operating in a team that have a shared goal. So somehow we aim at having a mixed team that includes where theory of mind and different levels of theory of mind, because of course you can go quite deep. I think we're talking about second or third order of theory of mind. And then if we want to do that, then we need to move beyond. I don't know if you are familiar with this term of human in the loop. So that's always, you get a feedback from the human. But the idea is that in order to achieve collaboration in hybrid intelligence, we need to really do a step forward and aim for something that we call synergy. And we are still at the step of defining what we really mean by synergy, because the hybrid intelligence is a project where many people from many scientists from different fields come. So each one of us has different definition. But we really want to aim for synergy and reciprocity in a team. And therefore, we have a number of challenges that arise. So how do you perceive social behavior within the collaboration? So using language and vision, maybe the agents need to understand what what is the behavior that the person in that team is going to have. How do you communicate? So how do you use language? How do you use dialogue? We have a mixed team, so we have multimodal interaction into the play. How do we understand joint actions? So the team is collaborating in synergy, so there are joint actions that need to be achieved, and some actions need to be achieved by the human and some by the machine. And how do you understand the most important social norms that are for the teamwork? So who is what is the power relation? Who is the leader and who is the? Is there any kind of favoritism? And one example of something that Tiffany, this is one of our PhD students, has been working on is on gathering a data set. So she's a social scientist, she's studying human cooperation, and the idea is to try to gather data about partner selection. So how do we work in teams as humans? And then once we gather this information, we can use it to study how to adapt this into a mixed team. And then she's using social psychology theories, so mostly she's studying interactions between dyads, so pairs, and she's been collecting multimodal data, so both audios and videos about people working in teams. She's been measuring personality, trust in personality of the players, how much the players trust each other within the team. Also, how much anxiety can they develop? And this into she's been giving the participants a collaborative task. So the social scientists sometimes, most of the time, they give the participants some sort of games where you have a task where you need to maybe distribute money or maybe do some exchange. And really the goal was to understand and predict what was the interdependence of the players into this social interaction. If then the follow-up step will be to try to replicate these experiments and apply what we learned into a human-robot interaction scenario. If you are more interested, I always put the references, but if you go on our website, which I'll show you at the end, we have all the information that you can find. So moving on to adaptivity, that's maybe also something that you might be more familiar with. I mean, I don't really know what your background is, but from the people I've met so far, I understood that that's quite a mixed audience, so I'm quite happy with that. So obviously, hybrid intelligence also relies on machine learning techniques, because part of our community is also machine, the AI, machine learning AI side. And the idea, I don't know if you know these comics, XKCD. This is one of my favorites. So the current state, I will let you read the comic and then I will talk about the slides. The current state of machine learning, that it's really, you steer the pile if something is not working and try again. So it's not able to adapt to changes if your data are changing, so changes in the environment, changes in the team. If the team is changing, then you need to gather your data again, train your model again. And it's not really able to balance between safety and reliability, so it pushes more on the reliability. We've seen cases that can lead to unseen consequences. And we do have the state of the art that is now moving into transfer learning, multitask learning, even meta learning, which I learned recently about. So you learn from the metadata about your experiments. And really what we would like to do is not really, moving from the strong assumptions that if you have historical data you've been training your model on, and then you get new data which are exactly looking like your historical data, so there's nothing changing in your environment. This is too much. It's never, in the real world, this never happens. Think about the machine bias case that happened in 2017, if I'm not mistaken, where a machine was trained on some data and then new data comes out and suddenly some guys are detected as being criminals even because their data look similarly to the one that the machines were being trained on. This assumption is too strong, so it's better to introduce the idea that the machines need to have a feedback from the environment. So that's reinforcement learning. I think you've heard about it, which means that the machine receives an observation, perceives something from the world. It acts. It acts upon this observation, and then it's the world. That the environment that gives a reward based on what the action was. And if this word is changing, also the reward is changing. So indeed, you can always try to use this feedback and use these dynamics in any kind of different world and different environment. So we want to try, in hybrid intelligence, we're really studying, there's a whole special interest group on reinforcement learning because we really want to try to apply these techniques in a way that we can develop machines that are better able to adapt to the environment. And there's a number of challenges that we need to develop if we want to talk about adaptive hybrid intelligence. Especially when it comes to learning reusable and safe behavior. I think safety is one of the big keys here. We want to try to teach machines, okay, preferably don't do this, embed these into the loss functions, for example. Maybe we want to embed this, how do we do this symbolically? So never do that. This is a rule and you shouldn't be doing that. It's a symbolic constraint. You can try to restrict the exploration process of the agent, so like don't try to do that. And also as a preference in the exploration process, so preferably try not to do, try this and not that. More importantly, the idea behind using reinforcement learning is to try to optimize over sample efficiency. So try to learn in fewer trials, because one of the things that machine learning relies on is huge amounts of data that in the real world you don't really have. I mean, I guess if you're working in robotics, that's one of the main issues. And in terms of like optimizing for sample efficiencies, these Andreas and Niklas, there are two different projects, but they've been working on similar tasks. They're really trying to develop these hybrid intelligence agents that learn through interacting with the world, and the world can be a human, or it can be just a representation. They obviously use synthetic reinforcement learning settings, so we need to start small. I guess if you've been, many of you are PhDs, you know that you should start small when you have a problem. The idea is that humans and agents, so the mixed team, use the shared representation. This can be either a causal model, it can be a knowledge graph, it can be these foundational vision language models, which I learned about recently as well. It's very nice because every time, I mean, we are so many that there's so much to learn all the time. And the goal is really, what they managed to do is to use this shared representation to improve over the number of samples you can learn upon, and also to generalize over sample data, over unseen data. So that's one of the things that machine learning is still struggling. Okay, depending on where we are looking at. So some say these language models are able to generalize. We can discuss about it. But these are small steps and small ideas on how to achieve this adaptivity in hybrid intelligence. Who's dealing with ethics in this room? Safety? Okay, a few. Let's see if you know these terms. So what do we mean by responsibility? I don't know about the people online, but why do we want responsibility, safety, and ethics into this picture? AI is increasingly being the key in important decisions, both for individuals and in society. So we use that to select candidates. I mean, I don't, but maybe others do. Financial decision, medical screening. I mean, if you've been working with medical companies use that a lot. And also for society. So you have fake news detection, hate speech detection. What are the reasons for these decisions? So why the machine takes a decision? We still don't know. So this explainability, transparency is still not there. We often don't know why the machine is giving us a given prediction. It cannot be disputed. You cannot really argument with a decision. The machine says, okay, that's it. This is what I predict, and you cannot say, oh, you're wrong. And you really don't know, even if you get an explanation, they're never ground into the context and the society and the culture where this is being developed. So it's not really grounded in any values, norms, or societal goals. And that the idea is to move from the classical AI approach, which is the one of implicitly coding the human values into the machine. So it's really the software engineer or the algorithm designer that encodes, that decides which are the forbidden actions and that decides not to encode them into the system. And the robot is not really, the system is not aware of why that's the case. So it cannot explain and it cannot even act upon that. What we want to do is rather to move into a sort of different setting where the ethical values and ethical constraints are encoded. We say ethics by design. So in the design of, when designing a system, we also encode ethical norms and values so that the system knows which values are forbidden and why they are forbidden in a way that you can also it can also take actions according to these constraints, and also maybe adapt its behavior. One of the ways we try to achieve that is through argumentation theory, and this is really one of the areas in knowledge representation. There's a small community, there's not so small community that has been working on argumentation theory. And the idea is really that we can have, so these are, the pictures you see are examples of argumentation structure. So how do you build an argument is that you have claims and maybe sub-claims, and then you do give premises or statements or counter-arguments to a statement. And the idea is to use this argument. There's many of different structures, so these are just examples. But no matter, it's not really important for this talk. The idea is just that we have these structures and we want to encode them directly into the system, and then the system is able to create the links that you see between the claims and the premises, or maybe the rebuttal or the counter arguments. And then the actual content of the arguments is provided by the humans. So it's really a mixed team in this sense. And this can be performed interactively in a multimodal way. It can be done by extracting information from text. So we do have from knowledge graphs, for example. I'm going to show you a couple of examples in a second, but then the question is really how the question that we're trying to solve in this area is really how we're going to account for ethical values during the computation process. So we don't want to extract this at the end, but we want these ethical considerations to be taken into account throughout the whole computation. We need methods to identify who are the stakeholders involved in a process, what are their values and goals, so that we can the conflicts and maybe aligning values and goals within the team. We need to encode the moral reasoning that we have as humans into the system. And we also need to have a sort of runtime exchange. So we want to allow humans to express their values during the interaction with the system. So it's really live, and that's really challenging. But we have a couple of PhD students that are working on modeling societal values and feeding them into the system. So it's really designing systems that encode this kind of information. They work on systems that they call them socio-technical systems. So these kind of systems that support public administration, hospital decision, court and juries. The idea is to try to prevent. Some of them. So one of our PhD students is working on preventing harm, socio-technical harm. So is my machine creating stereotyping or bias? And then they use situated design, so a design technique to try to represent the context around where the system is operating in order to avoid the system to create the stereotypes. And then one of Enrico, another PhD student of us, is working on detecting the preferences. So in a group of stakeholders, what is the ranking of preferences, value preferences that the stakeholders have. So he detects that he's using NLP to extract these, and then he kind of comes up with a joint decision on the preferences using social science techniques. So these are attempts, but as you see, is still this idea of encoding this societal information into at design level in a way that you can then have a better interaction at runtime. Talking about explanation and trust, so responsibility and explainability are really linked together because, let's say, one goes with the other. We've also been looking at this explainable AI. I don't know if any of you is looking at explainable AI as part of their work. Okay, good. So some hands-on. The approaches for explanations are really data-driven. So you think of Lime and SHAP. If you they are systems that try to estimate the importance of a feature when you train your machine learning model. And let's say, for example, saliency maps. These are the typical ways. It says, okay, the area, the red area I detected is the one that tells me that this is a bird. But then most of the time, these systems can only be understood by people from the field, some people working maybe on explainable AI, not really from a user, which means they lose the trust from the users. And this trust is essential when we want to, in collaborations in heterogeneous teams. Also, most of the time they can be wrong. So we also want to try to understand why this is happening. If we think, on the other hand, of how we explain as humans, we use our background knowledge. So this is a trick I always like to do, and it's still working. So you're familiar with Google Trends? Google Trends shows you how much a term has been searched on Google search over time. So if you go on trends.google.com and then you type a word, it shows you, okay, this is really when it was searched. And this is a trend line for the term A Song at Night and Fire between 2012 and 2018. And then you see this very regular line going up and down. Do you know why? New season of what? And what is Game of Thrones? Of? How much background knowledge did you use to come up with that explanation? So I didn't write anywhere Game of Thrones, right? We agree. And then this is actually indeed the beginning and the end of the season. So we use our background knowledge to make steps and then come up with an explanation. We don't only do this ourselves, but we do this in a shared way. So our background knowledge is shared, and everybody knows that this cannot be a shower cup because she the queen. I should change the picture. It should be the king, but the talk comes from before. So everybody knows that it cannot be a shower cup because she was the Queen of England, of the United Kingdom, sorry. So the idea is that this information, these steps, and I really like what we just did because we really hop over different concepts and relationships. This information is really encoded in knowledge graphs. So knowledge graphs are these data sets in the form of graphs where you have concepts and relationships between concepts. And most of the time, they contain both information about, say, classes and relationships, but also factual data. So it's not only a movie, an actor plays in a movie, but also DiCaprio played in Titanic. And similarly, they contain information like the queen wears a crown and not a shower cup. I mean, she probably used to wear a shower cup at some point in her, but the distance is much farther. So the idea is to achieve explainability using a combination of data-driven technique and knowledge graph-based technique in order to be able to better explain data and data prediction. And then the real question is, the questions that come out are how are we going to build faithful explanations, because knowledge graphs also create some issues in quality, for example. But we want to explain the mechanics of the model with a certain level of abstraction. We want to recreate rationality, so we want to give a justification for the decision. We want to create contrastive explanations, so not only, okay, I think this happened because of that, but you also create a counter argument. So this didn't happen instead of this other thing. And we also want to, since we're talking about mixed team, we also want to talk to include social explanation. So can we relate the explanation that we've given into the goals and the beliefs that the person in front of us has? Just to give you an example on how can we explain with knowledge graphs, this is a system I have been working on well before deep learning was coming out. You basically take any output of a machine learning system, and then you plug a knowledge graph component. So you take information from a knowledge graph, and you try to link the, is it a pointer? Oh, yes. You take the output of the machine learning component, and then you take information from the knowledge graph. You kind of steer together. If you're interested, go and look in the paper. I think it's easier. And then you try to come up with an explanation for this output. So somehow knowledge graphs provides the background knowledge that we've been building to explain why people were searching for a song in Ice and Fire. And actually, with this idea, we've been able to explain quite a number of things. So we use this over the years. We use this small idea to explain, okay, why people search for a song in Ice and Fire, and that's because there was a new season of Game of Thrones. Or maybe why countries that have, so this was Istat data, and so why countries that have a female low literacy rate might be classified as so, and that's because they are least developed countries where education for women is not as accessible. So that's one way of showing you how we can use not only, we don't need to rely only on sub-symbolic systems, but also the symbolic system is there. I'm almost done. Finally, after all these, we are talking about hybrid intelligence, but we want to build a theory for hybrid intelligence. So this is a new field we are talking about, and we want a theory behind this field, the same way AI has some theories, and psychology and human-computer interaction. We call these three areas the hybrid intelligence parents. And if you want to build a theory, you need assumptions, you need language, you need questions, you need methods, metrics, and results. So this is how you, let's say, a kind of recipe for building a science. And then the question is, should we look at what our parents have done? So am I going to use the methods from AI, from psychology, and human-computer interaction? Or are we going to develop our own? And we are trying to understand this little by little. So just to give you some assumptions for field related to hybrid intelligence. From AI, we get that intelligence is computational, that systems have an agency, then individual agents can act rationally. From psychology, hybrid intelligence inherits that human behavior can be predicted through experiments, and then we humans are information processors, among other things. And from HCI, we inherit that humans and AI systems are complementary, so there's strengths and weaknesses, but the relationship between humans and machines is asymmetric. It means that we should not have the same rights, for example. We've been trying to develop, so that was the an attempt to look into the parents of hybrid intelligence, to build assumptions for hybrid intelligence. And then we tried with Victor and Stefan at the Free University, we tried to build a language for hybrid intelligence. So what we did was to come up with an ontology, a set of common roles, a fixed terminology for all the systems that deal with all the hybrid intelligence systems that we've been developing. So we really looked at all the systems that our students use, or maybe in our hybrid intelligence consortium use, and we've come up with an ontology of common roles and recurrent tasks, which can be either classical tasks that the mixed team has to achieve, but also hybrid intelligence specific tasks like team awareness, creativity. It doesn't really matter what we found out. It's mostly to show you that we did work on identifying our own language. We didn't necessarily inherit that from the other fields. And we use that to compare hybrid intelligence scenarios, but that's let's say, less relevant. So this is to say that if we want to build the science, we need to proceed in steps. I've been showing you some assumptions. I've been showing you some shared language. The care lines that you've seen are part of the questions that we want to answer. If we want to make a big recap, and then I'm done, hybrid intelligence, you can remember as a field where we try to use AI to extend, augment, enhance human capabilities, as other tools in science have done in the past, with the idea of collaborating in synergy with humans instead of replacing that. So if you meet Elon Musk one day, just remember, hey, hybrid intelligence, we don't want to replace human, even if he still aims at doing so. And then I've been showing you the main hybrid intelligence functionalities with some examples for collaboration, for adaptivity, for responsibility and explainability, and how are we trying to achieve a theory of hybrid intelligence. Just to give you, after all this, the last slide, this is an application we are really working on, so it's not only in the air, but we are actually practically working. That we have this robot surgeon, we call it, or microsurgeon, and the idea is that we have this couple system. So I just learned that some of our colleagues were in the operating room trying to study how to model the problem, and I was like, I'm so jealous. I also want to come. So you have a couple systems, so a human and a machine, and then they are learning a very high-quality task performance in this microsurgical environment. So it's something where you need to be extremely profile, and then the situation is really that the human has an incentive to teach the robot learns from the human experience, it asks for questions and permissions, and then it refers to the human. And then we try to measure the success of the process by a successful patient outcome, obviously. And we are structuring this in 3 different tasks where we have data exploration, communication, and a communication interface, and a collaboration dynamics. And we are applying a number of techniques for these different tasks. If you want to know more, come to Amsterdam. We are more than happy to have you around. So this is a huge consortium of 6 or more universities in the Netherlands. So I haven't been showing you my work, but this is the work of everybody all together. Mark is also here. He's also part of the Hybrid Intelligence Consortium. We do have a conference that we organize with a Humane AI Net program, which is another European consortium on hybrid intelligence. We organize this together with a hybrid intelligence center in Sweden and in Denmark. I highly recommend you to look at the conference. It's Hybrid Human AI Conference. Next year is going to be in Sweden. We already had 2 very successful editions, one in Amsterdam and one in Munich this year. We are more than happy to have students and start collaboration. If you are interested, just approach me. And that's it.